The second big formula on our Cartesian plane formula reference sheet is the distance formula. So we've already calculated the slope formula. Now we're moving on to the distance formula. And once again, I want you to take a sheet of paper. This one isn't very big. And I want you to kind of free associate and give yourself a little word web. What do you remember about the distance formula? We've come up with the formula before, and we kind of went through the steps of how you would build it. How much of that do you remember? And can you figure out how those bits that you remember kind of turn into what the formula is? Pause the video if you need to take a minute or two for that, and then let's talk about it together. All right, so once again, this diagram is going to look quite a bit the same as the slope formula. So we had 2 points, and we were thinking about the line segment between them, and we were thinking about rise over run. That was what slope was. Here, we want to think about the distance. All right, and we're going to wind up doing a very similar diagram in that we're going to have a horizontal line and a vertical line. And once again, horizontal lines and vertical lines are perpendicular to each other. So we've got that right angle there, and that gives us a right triangle. And just like before, we know that this side is the change in the x values, and this is the change in the y values, or y2 minus y1 and x2 minus x1, however you want to think about that. All right, so now we've got this right triangle, and we've got the expressions for the 3 sides of it. How can we connect the lengths of the 3 sides of a right triangle in a formula? Do you remember the name of that formula? It's a big one. It starts with a P and it's long. That is the Pythagorean Theorem. And the Pythagorean Theorem, most of the time, if we have A, B, and C, is that A squared plus B squared equals C squared. So what I'm going to do is I'm going to just take that, except I'm going to use these 3 expressions instead of the letters A, B, and C. And so on one side, I've got D squared, and on the other side, I've got x2 minus x1 squared plus y2 minus y1 squared. All right, and so all we need to do now is turn this into something where we've got d alone instead of d squared. So what do I have to do to a d squared to turn it into d? And then I need to do that to the other side of the equation. And the inverse of taking the square of something is taking the square root of it. So x2 minus x1 squared plus y2 minus y1 squared. All right, that is what the distance formula is. Once again, in this column, I want you to write down some keys. This process, express it in your own words so that you can think about how you would be able to recreate this equation if you needed to do it, because you will need to do it someday. And what is the distance formula good for? Well, just like we said here, the distance formula lets us find the length of a line segment. And so this is very good if we want to figure out if 2 line segments are, what would that be? So parallel and perpendicular, we would think about the slope of the lines. If two line segments have the same length, what's the vocabulary word we turn that into? They are congruent. All right, so congruent line segments are really helpful things to know about. And so we can prove, once again, we kind of had techniques for doing that, or we would be told that something was given, or we would use CPCTC to show the 2 line segments are congruent. What we can do when we've got coordinates is we can use the distance formula to use calculations to find the length of the two line segments. If they're the same, boom, they're congruent. If not, they're not congruent. It's that easy when you've got the calculations, but you need to know the distance formula. All right, so have that second column or that second row filled out, and in the next video, we'll wrap up with the midpoint formula.